The parallelogram shown has four sides of equal length. So a parallelogram of all sides equal is called rhombus, right? And now we also see that this angle is 60 degrees. That means this angle will also be 60 degrees. So these remaining two angles will be 120 degrees each, because two adjacent angles add up to 180 degrees. So if this angle is 60, this angle is automatically 120 degrees. Properties of rhombus: diagonally opposite angles are equal, all sides are equal. Another property of rhombus is that the diagonals are perpendicular bisectors of each other. Now let's see whether it's useful here or not. What is the ratio of the length of the shorter diagonal to the length to the longer diagonal? Alright, now we were just talking about the properties of diagonals in case of rhombus, and the question is entirely about the diagonals. So here you see a blue diagonal, that is a shorter one, and red diagonal, that is a longer one. The question is, what is the ratio of the shorter diagonal to the longer diagonal? Alright, let me also name them. Let's say the shorter diagonal is D1 and the longer diagonal, which is the red one, is D2. So what we need to find here is D1 over D2. That's the question. We clearly see that 60 degrees, in any question when you see that 60 degrees is put into use, it's always about equilateral triangle or 30, 60, 90 triangle. Now here, let me redraw this diagram so that we can see what we have here in the bigger diagram, because the 60 degrees is making this question pretty much easier. Now see, what I'm doing here is I'm once again drawing the shorter diagonal. But what happens with this shorter diagonal is, because these two sides are equal and this angle is 60 degrees. So what we understand is that the remaining two angles should also be equal in this triangle, and sum of the angles in a triangle is 180 degrees. That means each of this triangle will be 60 degrees each as well. Alright, which means that if I assume that the side here is x, then this will also be x and this will also be x, right? Which means I understand that d1 is equal to x. Now the question is all about d2. So let me draw the diagonal. And now all you have to do is you have to just look at from the easiest perspective. There are two ways or three ways we can find this out, but the easiest way that I see is that you see that this triangle, if I say A, B, C, D, then triangle ABD is same as triangle BDC, and both are equilateral triangle. And AC is 2 times the height of the equilateral triangle. The height of equilateral triangle is given by root 3 by 2 of side, and the side of this equilateral triangle we have assumed is x. Actually this BCD will also have the same sides x, so BCD is also an equilateral triangle, which means the length of AC is root 3 times of x. That means we see that d2 is root 3 times of x, which means the d1 upon d2 that we needed to find out will be equal to 1 over the square root of 3, and the answer is option D. Although we have got an answer, but I also want to share with you another method to answer this, to find out the length of AC. So let me write it down. This is method 2. Another method to look at this will be that if you see this particular triangle, you can see that this is 60 degrees, the diagonals bisect at 90 degrees, which means this angle is 30 degrees, which means you could also have said that half of AC will be the side opposite to 60 degrees, right? Side opposite to 30 is x by 2, because it's half of this diagonal BD. So side opposite to 60 will be root 3 times of x by 2. Remember, I'm using the property 30, 60, 90, in which the ratio of the sides is 1 to root 62. Now if you see this, you can again get AC is equal to root 3x. That's another method to answer the same question, right? And there could also be another different method. We could have taken triangle ABC as an isosceles triangle, and in that also we could have figured out AC. But I hope we have already enough methods here to find out the length of AC. Thank you so much.